moments and tilting. Example 4, we have a non-uniform rod of weight 40 newtons. So the 40 newton force due to the weight is not right at the center. It's held by two ropes. The tension in each rope is different. At the moment this is not about to tilt. A weight is added to one end of the rod. Now we need to look for a pivot point to look at tilting, and the pivot point is at C. When this rod is about to tilt, the tension in this rope will be 0. The effect of tilting is that if we were to get rid of that rope completely, the rod would remain perfectly balanced. To get a better understanding of why point C is the pivot point and why at the point of tilting the tension in the rope is 0, let's have a look at what would happen if the rod did go on to tilt. And if it does tilt, this side will come down and this side will move up like this. So it was this and it's tilted, so now we've got this situation, and we can see there is some kind of rotation around this pivot point, and the rope has become slack, so the tension in the rope is 0 newtons. Now on a diagram, this system with various measurements added looks like this. So this is what it was before and this is what it is now. So we have to work out the value of x, which is the distance between the center of gravity where the weight acts from point A. So as C is the pivot point, at the point of tilting the tension in D will be 0. The tension in C in this rope is unknown. When we take moments, we don't want to have TC, the tension at C, in our calculation. So taking point C as the point about which we take moments is sensible, because the distance from this force, TC, to our point C is 0, so it won't be included in the calculations for moments. So taking the clockwise sense as positive, moments around point C, we have the 40 Newton force times the perpendicular distance here to point C, so that's going to be the x minus the 3, and that's a positive moment because it's going clockwise around point C, and then the 25 Newton force, which is pointing downwards, so in this direction we're going anti-clockwise about point C, so force times perpendicular distance, and this time the moment would be negative because it's anti-clockwise, and then we just solve to work out x. For practice, try these questions.